Welcome back to Algebra 1. Okay, so we're going to do the Unit 3 Systems of Equations review for your test on Tuesday. So this question number 1 says, how many solutions does the system of equations have below? These are both set up in standard form, so I would go start by solving using elimination since they're in standard form. To get these to eliminate, you're going to need to multiply one of the equations by some number. To get the x's to match, I'm going to multiply by 3 to create a new equation. So the top's going to stay the same, so I have 3x plus 3y equals -9. The bottom equation is going to become 3 times x, which makes 3x, 3 times -y, which makes -3y, and 3 times -13, which is going to make -39. Ooh. Okay, so in this case, since these are both positive, you could subtract them, but if you look, your y's are automatically going to cancel anyways because they're already opposite signs. So I'm going to cancel those out, and since they have opposite signs, I'm going to add everything else. 3x plus 3x makes 6x, and then -9 minus 39 makes -48, and then I don't want to make any silly mistakes, so I'm going to grab my calculator. Okay, so now I have it throughout this. Okay, if I divide by 6 and divide by 6 on both sides, x is going to equal -8. You could technically stop there. As soon as you have an x value, you know that you're going to be able to plug this back in and get one solution. If you want me to plug it in really quick just to show you, I'll show you. I'll use the bottom equation. X minus y equals -13. X is -8 minus some number y is going to make -13. Using opposite operations, I'm going to isolate the y by adding 8 opposite operations. -y equals -5. Divide by -1 because you cannot leave y negative, so y equals +5. So if you get a solution, you know that it's going to have one solution. No solution would be where your x's and y's cancel and you get like 0 equals -48. That's no solution. Infinitely many solutions would be whenever these cancel, but it makes a true statement like 0 equals 0. And exactly 2 solutions is there to throw you off, because if you have 2 linear functions, you can't have 2 solutions because it's going to be one straight line and one straight line. So if they cross, it's only going to be at one place. So number 2, we're going to do the same exact thing, use elimination to solve this. They're already in standard form. The x's line up, the y's line up, the constants are over here. So the y's don't automatically cancel. My x's, I'm going to multiply the bottom equation by 2. The top equation is going to stay the same. So I have 2x plus 5y equals 3. Distribute a 2 into the bottom, I get -2x. 2 times 3y makes +6y. 2 times -7 is -14. Since they already have opposite signs, they cancel and I add everything. You only subtract if they are both positive or both negative. So 5 plus 6 is going to make 11y. 3 plus -14 or 3 minus 14 makes -11. Divide by 11 on both sides. Y is going to equal to -1. Then I'm going to plug that back into one of the original equations. So I'll use the top because there's more positives. 2x plus 5y equals 3. Plugging in y, so 2x plus 5 times -1 equals 3. 5 times -1 is -5. Using opposite operations, I'm going to isolate the x by adding 5 to both sides. So I have 2x equals 8, so x equals 4. So my coordinate point is 4, -4. This is where they would cross. Number 3 says, at a sale on winter clothing, Cody bought 2 pairs of gloves and 4 hats for $43. Tori bought 2 pairs of gloves and 2 hats for $30. What are the prices of gloves and hats? So first thing you need to do is you need to write an equation. 2 pairs of gloves could be represented with 2G. 4 hats could be plus 4H, and he spent a total of $43. The other equation for Tori would be 2 pairs of gloves and 2 hats plus 2 hats for $30. And then since the G's already match, I'm just gonna subtract them to get the G's to cancel. So I minus them. They're both positive, so I'm gonna subtract them. That will make 0. 4 minus 2 is 2H. 43 minus 30 is 13. Divide by 2 makes 6.5. Which makes sense because a hat can be $6.50. So now to figure out how much my gloves are, I'm gonna plug 6.5 back into one of my equations. I'm gonna use the one with the smaller numbers. So I have 2G plus 2H equals 30. So I have 2G plus 2 times 6.5 equals 30. 2 times 6.5 is 13. So I'm going to minus 13 to both sides using opposite operations. 30 minus 13 makes 17. And then divide by 2 on both sides. So G equals 8.5. So it's $8.50 for a set of gloves and $6.50 for a hat. Okay. Number 4, it says 2 lines have the following equations. At what point do they intersect? So people get confused with this and they think since they're lines, I have to make a graph, and because you're talking about where they intersect. But since they're in standard form, you can use elimination. You're not given a graph, so don't make your life harder than what it needs to be. So they're in standard form. Now in this case, I can't multiply 2 by anything to make 5. I cannot multiply 2 by anything to make 3. So this requires double multiplication. So the easiest way to do this is just to switch the 2 values in the front. So I'm going to multiply the top equation by the bottom number, which is 5. And I'm going to multiply the bottom equation by the top number, which is 2. That way, whenever I distribute, my x's will have the same coefficient. So if I distribute to the top, I'm making a new equation, which makes 10x minus 15y equals 21 times 5 is 105. The bottom equation, I distribute 10x minus 4y equals 50. Since they're both positive, you cannot add them because that'll make 20x. You have to subtract them. So I minus them. Make sure you're minusing the entire time. 10 minus 10 is 0. They cancel. Negative 15 minus negative 4. If you're minusing a negative, this really becomes a plus. So negative 15 plus 4 makes negative 11y. 105 minus 50 is 55. I have to isolate the y by dividing by negative 11. So y equals negative 5. Now, this is half of the coordinate point. I want to know the full coordinate point when they intersect. So I already know I'm going over some amount and I'm going down 5. I'm going to use the original equation. I'm going to use the top one just because 2x minus 3y equals 21. And I'm going to plug in my y value, which is negative 5. 2x, now I have negative 3 times negative 5. That's going to make a positive 15. So I have 2x plus 15 equals 21. Move the 15 over using opposite operations, so it became positive, so now I'm going to minus it. So 2x equals 6. Divide by 2, x equals 3. So the coordinate point where they cross is 3, -5. Number 5, it says, is 1, 3 a solution to the system of equations? So you could solve this and see if that's what you get, or you could technically just plug in the numbers. So I'm gonna just plug in the numbers because that's actually gonna make my life easier. If my original equation is 4x minus 2y equals -14, I'm gonna see if x is 1 and y is 3, that will produce -14. 4 times 1 minus 2 times 3. Does it equal -14? That's basically the question. If it does work, then I have to try the next equation as well. 4 times 1 is 4. -2 times 3 is -6. I want to know, does this make -14? 4 minus 6 makes -2. -2 does not equal -14, so this is not a solution. Nope. If this worked, if it said -14 equals -14, I would then also have to plug the coordinate point into the bottom equation and check if that one works as well. This coordinate point would need to work for both equations, not just one of them. So in this case, the first time it did not work, so I don't even need to bother checking the second one. 6 says, Alina found a used bookstore that sells pre-owned DVDs and CDs. DVDs cost $9 each and CDs cost $7 each. Alina can spend no more than $35. So her max is $35. If I have $35, I can't spend more than that. So it says select an inequality in standard form that describes the situation. So if it's $9 for a DVD, X is the number of DVDs. So it's $9 for a DVD, so 9 and X need to go together. Y is the CDs. CD costs $7. Now I can't spend more than 35. I know 35 is my constant. I need to figure out which one of these signs best represents this. Well, I actually have two options. So since I can't spend more than 35, I can spend 35, meaning that this can be or equal to. No more than 35 means I cannot spend 36. I can spend 35, I have $35. I cannot spend 35.50, 35.25. So, and then you have to make sure your variable matches. So this one is the one that matches it. 7 says solve the system of equations. These are all in elimination. These actually already cancel out. You could subtract them to get the x's to cancel because they're both positive, but look at your y's. Your y's are already opposite signs, so those easily cancel. If they're already opposite signs, you're adding everything else. X plus x makes 2x. -3 plus -3 makes -6. Divide by 2, divide by 2. X equals -3. Now to plug that back in. So I'm going to use the top equation. X plus 3y equals -3. X is -3. Lots of 3's in this case. Using opposite operations, I'm going to add 3 to both sides. So I have 3y equals -3 plus 3, which is 0. Divide by 3, divide by 3. Y equals 0. So the coordinate point where they cross is -3, 0. Okay, to flip my paper. 8. This is solving systems using graphing. So if I'm providing with a graph, I want to see the graph. This is a test. I want to see that you can use each method. I don't even know if we've done substitution at all. So since it says graphically, I want to see the graph. So this is already in standard form or slope-intercept form, which is y equals mx plus b. B is where you begin. So I'm going to start at +2. This is a y-intercept. So on the y-axis, I start at +2, put a point. The slope tells me how much I'm rising and running. Since it's negative, I'm going down 1, to the right 2. So So down 1 to the right 2. And I'm going to keep going. Down 1 to the right 2. 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 I'm also going to extend in the opposite direction. So I'm going to go up 1, back 2. 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 This is my first line. So when I'm graphing the second equation, they should cross at some point that's already plotted on this graph. I'm trying to find a different color to use. The other equation is in standard form. So x plus 2y equals 4. I need to isolate the y to graph this. So I'm going to move the x first. The x is positive, so I'm going to minus it to both sides. Minus x, minus x. I get 2y equals, x should go first, plus 4, because 4 is positive, in the back. Now I have to isolate the y completely by getting rid of this 2. So I divide every term by 2. Y equals, this is negative 1 over 2, so negative 1/2 x plus 2. B is where I begin. M is how I move. So I start at 2, and then I go down 1 and over 2. Oh my gosh. Every single point is the same. That's weird. What does that mean? That actually means that there's many solutions, because this line and this line come out to be the same exact thing. So this is infinite or many solutions. You could also say all real numbers. Okay, so let's go to number 9. We're going to graph this. These are inequalities. So these have to be shaded. You're looking for a double shaded region. This is a compound inequality. So what I'm going to do is I'm going to copy the first equation. Now, this is not in slope-intercept form. The reason why is because y is not completely isolated. So I have to get rid of the 2. So I divide every term by 2. I do not flip my inequality sign because I'm dividing by a positive. The reason why I canceled these 2's out and not this 2's, because 2 divided by 2 really makes 1. We just never write it. So in this case, they cancel, but I still bring down an x because that represents a slope of 1. Minus 4. Okay, so now I'm going to graph that. So I start at the b value, which is negative 4. My m is how I move. So since it's a slope of 1, I'm rising 1 and I'm running 1, going up 1 and over 1 because it's a positive slope. So rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Now this is a dashed line because it's not or equal to, so it's not including the numbers on the line. So I'm going to create a dashed line using these points. Since this says that it is a greater than symbol, that means I'm really shading everything above this line. So I'm shading everything above. So everything greater than this line using the y-axis for reference. So I'm going to shade everything greater. And I'm doing it really light because I'm in pen. You should not be using pen. Now I'm going to do the same thing for the other equation. The other equation is 2x plus y is less than or equal to 2. I have to isolate the y. So I'm going to move 2x to both sides, or both sides. I'm going to move it to the other side. So I have y is less than or equal to negative 2x plus 2. Okay. I could swear I just heard a little meow. I don't know. Okay, anyways, so this is the b. So I'm going to start at positive 2 on the y-axis. Pretend like this other line is not there. My slope is negative 2. So I'm going to divide, or I'm going to go down 2 and over 1. Down 2, over 1. And if you don't remember how to graph a line, you should probably go back and watch my graphing a line video. I'm trying to move fast. Up 2, back 1, up 2, back 1, up 2, back 1, up 2, back 1. This is not a dash line, it's a full line because it's or equal to, meaning it's including the numbers on that line. So you're not looking for the corner point where they cross, you're looking for a double shaded region. This is a less than symbol, less than, meaning I'm shading everything below on the y-axis. So I'm actually shading everything basically to the left-hand side of this line. So you're looking for the double shaded region. So if you're looking at this graph, you have a single pink area here, you have nothing down here, you have blue down here. This section is the section where they are holding hands. That's double shaded. So you can go back and make those darker if you would like. But make sure it's like distinctively different from the rest. These are all the solutions to the system. Any coordinate point in this region, not including the points on the dashed line. Okay, last but not least is 10. 10 says Julia and her sister Kate are making baby blankets to sell at a boutique. Julia has already completed 5 blankets and can finish 1 more blanket per day. Katie has already completed 2 blankets and can finish 2 more blankets per day. At some point, they will have completed the same number of blankets, write a system of equations, graph them, and write the number of blankets they both will complete. So for Julia's equation, if she has already made 5 blankets and it's 1 blanket per day that she can make, her equation would be y equals 1x, because that's the slope, that's the rate of change, plus 5. She already made 5. For Katie's, hers would be y equals 2x, because she can make 2 more blankets per day, and she already has 2 blankets completed, so plus 2. So starting with Julia's graph, I'm going to start at 5. This is the B where I begin. 1, 2, 3, 4, 5. My slope is 1, so I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. This is Julia. I'm going to make Kate's now. Kate starts with 2. That's where I begin. And then my slope is 2. So I'm going to rise 2, run 1. Because it's 2 blankets per day. Rise 2, run 1. Rise 2, run 1. And this is Kate's. Or Katie. So the coordinate point where they cross is after 3 days, they will both have knitted or made a total of 8 blankets. Hopefully this makes sense. Make sure you check your answers and be prepared for your test. Okay, bye.